Hi guys, and welcome to another video, and today we're going to be looking at finding the derivative from first principles. And when you find the derivative from first principles, remember that the question has to state find the derivative from first principles, and only then will you use this particular formula to find the derivative. Otherwise, you will use the rule to find the derivative. Now, one of the other things that we should know at this stage is that rate of change is basically gradient. An example of rate of change is basically speed equals to distance over time. And we're looking at average rate of change and instantaneous rate of change. Those are the two different types. Now, find the derivative from first principles. What I'm going to be focusing on in this particular video, we're going to be looking at substitution. That is, in our function, we're going to substitute x plus h wherever we got x. Write down the formula, which is basically, this is the formula for finding the derivative from first principles. Limit as h approaches 0 of f of x plus h minus f of x over h, which is basically the same as the gradient formula y2 minus y1 over x2 minus x1. Only difference is that x2 minus x1, basically 2 points which is coming very, very close to each other. Now, substitute f of x plus h and f of x into the formula, simplify and remove h as a common factor, cancel the denominator h and substitute h equals to 0. Check your answer using the rule. What is the rule for the derivative? Now remember that if f of x is equal to kx to the n, then f prime x is equal to k n x to the n minus. Right, we'll be covering that in the next video, but I just wrote it there because we're going to be checking our answers using the rule. So let's look at this first example. Find or determine f prime x from first principles. So only if the question says from first principles are we going to use this particular formula. So therefore f of x plus h is equal to x plus h all squared minus 2 into x plus h equal to x squared plus 2x h plus h squared minus 2x minus 2h. Write down the formula. F primed x equals to the limit as h approaches 0 of f of x plus h minus f of x all over h. Let us substitute into this formula. So here we have equals to the limit as h approaches 0. F of x plus h is, here we've got x squared plus 2xh plus h squared minus 2x minus 2h. Minus f of x will be minus this particular function. So if you minus this function, you're going to change the signs. Minus x squared plus 2x. So you'll have minus x squared plus 2x all over h. X squared minus x squared. Minus 2x plus 2x. As you can see, we are simplifying and those terms cancel. So now we can remove h as a common factor. So we carry on writing limit as h approaches 0 until we substitute h equals to 0. So here we got h into 2x plus h, and what we left with minus 2 all over h. H and h cancels. Now we can substitute h equals to 0. So basically this term with h is going to equal 0. So we're going to be left with 2x minus 2. Therefore f prime x, the derivative, equals to 2x minus 2. Let's check our answer quickly using the rule. So if we check our answer using the rule, here it'll be 2x. So we got 2x minus 2. Alright. So 2x minus 2 is our solution. So therefore we got 2x minus 2, so we know that our answer is correct. Now let's look at the next example. In this particular example, it says determine f prime x from first principles. Remember, only if they say from first principles, then we will use the rule. So f of x plus h equals to 1 minus 3 into x plus h squared, 1 minus 3 into x squared plus 2xh plus h squared, which is 1 minus 3x squared, that's minus 6x h minus 3h squared. Therefore, let's write down f prime x, our formula. The limit as h approaches 0 of f of x plus h minus f of x all over h. Let us now substitute what we have for f of x plus h. So that's going to be limit as h approaches 0, 1 minus 3x squared minus 6x h minus 3h squared minus f of x is going to be minus f of x is minus 1 plus 3x squared. So we got minus 1 plus 3x squared all over h, 1 minus 1 minus 3x squared and plus 3x squared. So we simplify. Now let us remove h as a common factor. So that will equals to limit as h approaches 0. So we got h into minus 6x minus 3h all over h. H and h cancels. If I substitute h equals to 0 here, that will become 0. Alright, so what you're going to be left with? Minus 6x. So therefore, f prime x is equal to minus 6x. Let's go check our answer using the rule. Okay, remember the derivative of a constant is 0, and this will become, so f prime x equals to minus 6x. Okay, and there we got minus 6x. So that's our answer. Next example here we got determine f prime x from first principles if f of x equals to minus 2x cubed. In this particular example, once again, we will say f of x plus h, first step, minus 2 into x plus h all cubed. So now x plus h cubed, it's a binomial cube, so that's minus 2. X plus h cubed is basically going to be x plus h into x plus h all squared. Alright, so basically it's x plus h cubed is x plus h times x plus h times x plus h. Okay, so if we have to open this here, and minus 2 into x plus h, and here we got x squared plus 2xh plus h squared. We'll have a binomial type of trinomial, and we can take minus 2 into the brackets. Alternatively, you can learn, for example, what is x plus h all cubed? Well, you can kind of memorize it. So x plus h all cubed, alternatively, and you'll end up with the same answer, is going to be, so let us learn basically what x plus h all cubed is. Right, so let's look at an alternative. Okay, I'm sure all of us will be able to multiply this binomial times that trinomial. Binomial times a trinomial. So what if we had minus 2 into x plus h cubed, and we want to cut out all that excess work? Well, we can just basically learn what x plus h cubed is, just like how we hopefully have learned what x plus h all squared is. So minus 2 into, so that will be x cubed. We're going to cube the first term, plus 3 times x squared times h, plus 3 times x times h squared plus h cubed. So if you learn that x plus h cubed is x cubed plus 3x squared h plus 3x h squared plus h cubed, well, you can cut out all of that work there. So we will end up now, if we take minus 2 into the brackets, we'll have minus 2x cubed minus 6x squared h minus 6x h squared and minus 2h cubed. Alright, so therefore now we can write down the rule f prime x equals to the limit as h approaches 0 of f of x plus h minus f of x. That will be all over h. Now let us substitute what we have here. That's equal to the limit as h approaches 0. So we've got minus 2x cubed minus 6x squared. H minus 6x h squared minus 2h cubed, and minus f of x is equals to minus is plus, so that's 2x cubed. So therefore we're going to have positive 2x cubed plus 2x cubed all over h. So minus 2x cubed and plus 2x cubed cancel. Now we can remove h as a common factor, equals to limit as h approaches 0. Let's take out h as a common factor, minus 6x squared minus 6xh minus 2h squared all over h. H and h cancels. Now don't forget, all terms with h in it now when we substitute 0 will become 0. So that term there will become 0, that will become 0, so we're only going to be left with minus 6x squared. So therefore f prime x is equal to minus 6x squared. If we have to go and check using our rule, f primed x equals to 3 times minus 2 is minus 6, and subtract 1 from there, so we'll be left with minus 6x squared. And our answer is minus 6x squared, so we know our answer is correct. Next, so this is the last example, and this one involves a fraction. And I think if we have to look at these 4 examples, any one of these examples will appear in our examination. Determine f prime x from first principles if f of x equals to minus 3 over x. So step number 1, f of x plus h equals to minus 3 over x plus h. Right, so therefore now let's write the rule. F primed x equals to the limit as h approaches 0 of f of x plus h minus f of x all over h, limit as h approaches 0. F of x plus h is minus 3 over x plus h, and minus f of x, so that's minus will be plus 3 over x all over h. Right? Remember, minus f of x will be positive 3 over x. Right? And now we got limit as h approaches 0. So we have a fraction in our numerator. So therefore we need an LCD. So our LCD will be x plus h times x. So there's our LCD, x plus h times x. So we're going to be left with minus 3 times x is minus 3x, and plus 3 into x plus h. And here this is h over 1. Change division to multiplication, h over 1 becomes 1 over h. So let's now simplify, and we're going to be left with limit as h approaches 0. So we got minus 3x plus 3x plus 3h, x squared plus xh times 1 over h. Minus 3x plus 3x cancels, h and h cancels. If we have to substitute h equals to 0, which we are going to do now, that term would become 0. So what are we left with? 3 over x squared. So therefore f prime x, our derivative from first principles, is 3 over x squared. Let's go now check our answer using the rule. So using the rule now, remember, okay, so ignore that. So it's going to equals 2. So f of x is minus 3 over x would be minus 3x to the minus 1. Therefore, f primed x equals to minus 1 times minus 3 is positive 3x to the minus 2, which would equals to 3 over x squared. And as you can see, that's now our solution. So that's how we know that our answer is correct. That's how we'll find the derivative from first principles, right? So you're going to follow those simple steps, and let's just go over those steps once more. And the steps are as follows. Step number 1, find f of x plus h. Step number 2, write down the formula. Number 3, substitute f of x plus h and f of x into the formula. Simplify and remove h as a common factor. Cancel the denominator h and substitute h equals 0. Check your answer using Google. Learners, if you haven't subscribed already, subscribe to my channel JL Maths, or check out all these videos on jlmaths.com for absolutely free. And I'll catch you in the next video.